if we want to calculate this expression with multiple threads or multiple processes, this is basically how we plan to do it. We say, let's process P1, take care of tasks T1 and T2, which are basically evaluating A plus B. That's T1. And evaluating E plus F. Then we have process P2 taking care of T3, which is C plus D, and T4, which is G plus H. And then we have another process here, process P3, which multiplies, and P4 multiplies, and then P5 divides. Perfect. So P3 basically multiplies, so it's going to be this part. So it's going to evaluate this. Assuming that A plus B is already calculated. So let me make this clear. This is like T1 equals this. And this is plus, basically T2 equal to this. And this is basically T3. So all of these T variables are temporary variables that are calculated by P1 and P2. So P3 basically multiplies T1 by T3. And P4 is going to multiply T2 by T4, which basically means the second part of this, the second product of this expression. And then finally, P5, which is the last one, is going to do the final division. When P3 is doing this, it stores the results in T5. So T5 equals this, and then the sixth task is storing the result of T2 times T4 in a temporary variable called T6. And then the last task would be T7 equals T5 divided by T6. So this is the whole tasks, or the whole operation. We have to we broke this into 7 different tasks. And then we said, you know, each process either does one task like these 3, or does 2 tasks like these 2. Right? And then they're going to all work together to calculate the result. How they can do the operation? First, we need to make sure P1 and P2 start. So both P1 and P2 should evaluate these variables, these T1, T2, T3, T4, before P3 and P4 can actually do the product. Because P3 depends on T1, this is calculated by P1, and T3, which is calculated by P2. So as you can all agree, we must first let P1 and P2 do their job before letting P3 and P4 do their job, right? So there should be a precedence of operation between them. Like you need to first let P1 and P2 do their job, then P3, P4, and then what about P5? P5 should kick in at the very end, because P5 is dependent, operations are dependent on T5 and T6, which are evaluated by P3 and P4. So how do we make that happen? How do we synchronize these 5 processes? We need to use semaphores. How many semaphores are needed We only need 3 of them. So I'll tell you why. First of all, we should ask T1 to signal a semaphore. I'm going to start with S0, and then if we need more, we're going to increase it. So we say S0 dot V, or we can do V of S0 just to make it like C code. So we first signal S0 when we do T1 and T2. And then we are going to do another semaphore S0. That basically means when they finish their job, they will signal S0. Now P3 should wait on S0 twice. And S0 is a semaphore initialized to 0. So we say we have a semaphore S0 initialized to 0. Why to 0? Because P3 cannot proceed with this operation before we get 2 signals on S0. Right? So this is one semaphore. The other semaphore we need for P4. And by the way, I need to move these forward. So first we do these, then we do that. So we need another semaphore, S1, so that we can signal it here and signal it here, so that later we can wait on it before P4 kicks in. So by the way, let's put this on top. So for P4, we should do P of S1 twice. Why twice? Because P4 needs both T2 and T4. When T2 is evaluated, we signal S1 once. When T4 evaluated, we signal T4 the second time. And that's pretty much what we need, right? What about P5? P5 should wait for the value of T5 and T6 to be ready. So when T5 is calculated, we should signal another semaphore. Let's call it S2. So I need another semaphore. Let's call it S2. That is signaled. And then we should do the same thing for T6. We should signal the same semaphore. And then P5 should wait for that semaphore twice. Once for T5, once for T6, right? And that's pretty much it. All the semaphores S0, S1, and S2 are initialized to 0. In order to make you understand all of that, let me quickly tell you like what P and B represent. P is the wait operation. So P gets a semaphore. I'm just going to show you the operation that P is going to do. P is going to say if S is 0 or less than or equal to 0, then do nothing. So I can do something like this. While S is less than or equal to 0, just do a spin lock, don't do anything. And then when you get out of the spin lock, do S minus minus. And that's pretty much what P does. What about V? V is, I mean, this is not exactly how semaphore works, but this is like, it's gonna tell you what wait and signal means. We call this wait, and this is signal V, which basically increases S by 1. And yeah, that's pretty much it. So if you think about this code that I just showed you, whenever, first of all, S is, these are all 0. So neither P3 nor P4 nor P5 can execute any of these algebraic expressions. Why? Because P3 is waiting for S0, P4 is waiting for S1, and P5 is waiting for S2. Why? Because they're all 0, and then there's a while loop that says, if S is 0 or negative, just don't do anything, just wait, right? So they cannot do anything. The only two processes that can proceed initially would be P1 and T1, P1 and P2, and that's exactly what we want. We need to first evaluate these summations, right? So first we do these summations, and then when you do each of the summations, we do a signal on S0 and S1. So by the end of P1 and P2, we have increased the value of S0 and S1 by 2 units, because each of these V's are the plus plus. So at the end of these, S0 and S1 are both have value 2. So when you apply 2 P's, you're not going to get stuck in this while loop. The first while loop is going to be broken because S is 2, and then S becomes 1. The second while loop will be, the second P, or call to the function P, will not be stuck in this while loop because this is 1. And then S becomes 0 at the end of the second P operation. So both P3 and P4 can jump through these, jump over these P operations, because the S0 and S1 were equal to 2. And then they can easily calculate T5 and T6. And then when they finish, they both signal the same semaphore. P5 is waiting for this semaphore twice. So again, S2 was initially 0. After these two signals becomes 2, and then after, and then, you know, because S2 is 2, we can go through these P functions without getting locked. So this is called a spin lock. That is not the way semaphores work. Semaphores basically block the process and let them wait. But here we just want to make it very easy to understand. So that's why I put in a while loop. And at the very end, we are signaling S2, which is initialized to 0. I'm sorry, we're signaling yeah, I talked about that. So we're signaling S2 twice, and then we are waiting for it, and then we're calculating the value of T7, which is the final result. So we were looking for the value of T7, which is going to be calculated by P5, and that's it.